Okay, as mentioned in a recent announcement, I got my act together and cleaned up this spreadsheet. So let's see here. Hold on a sec. I'll put it all on here. So what you'll notice is that I still have the blocks, ruler, caliper, micrometer, and then the balance or the scale. And I got rid of this extraneous stuff on the left that I hadn't noticed earlier. And then what I did is instead of having these known values, I had them over to the right. I stacked them up beneath each. So now you have one ruler, calipers, and micrometer. And in the last video, we went over processing each individual tool, and we talked about converting diameter into radius, and we worked on filling in this table here. So what you can do now is you can simply take all your work that you did, and you could try to reformat your spreadsheet, but a quick way to do this is to just copy and then you just paste, and it has the formulas are there so you don't lose your work. And then when it comes down to here, you can do a similar thing. And what we had gotten to in the latest video is that we had everything up to here. We had we'd calculated the volume and the plus minus volume. And so you can just copy paste it into here. And I know why this is giving me a divide by 0, because this block up here is still blank, and I have to copy paste that over. So, I posted this. I don't want people to despair that they did all this work and it's going to go down the tubes, and it's not. You can just copy it all over. And let me see here. Now I can show you also a better way to do this. You can actually, instead of copy pasting the number, I just realized I could have just went equals and then clicked on this cell. And now that's nice, because if I see a mistake over here, then this would automatically update. And same thing with the plus minus, for example. I would say equals to the plus minus up here. That's up to you. Again, I don't want you to feel like you did a lot of work and you're throwing it out the window. Okay, so let's go here to my finished one. And this is just me looking at something and clear the contents. So we made it to the volume, we made it to the plus minus volumes, and it's pretty dramatic. Take a look here how the plus minus volume goes down from using the ruler to the calipers to the micrometer, right? It's pretty amazing, right? But at the end of the day, notice that, when we add in the scale, one of the things we learned from adding in quadrature is that the thing that has the larger error is going to dominate, and that's the scale. So we can go from the ruler to the calipers, and we see a reasonable change. But then when we go down to the micrometer, you notice it doesn't change very much, not as dramatically as it does for simply the volume. So one of the lessons we have here is that you only want to use the micrometer when it's absolutely necessary, And to really get the most benefit as far as the density measurement goes, we'd have to get a better weight mass measuring device. As this plus minus is just not. You see the difference here with the micrometer and this error is going to dominate. Okay, so anyways, let's go through it here. This last bit down here. That this is the second table in the lab manual. So we've got the volume, which is pi r squared times the length. So now we just have to take density is mass per volume. So now it's simply the mass value, and that's in. I notice I put the dollar signs there, and you can see right away that it's zoomed in too much. Let's go back out to 100%. And here it is. And so there's the volume, and I believe, where is it picking up the density from? Oh, it's picking up, the mass. It's picking up the mass from up here. And yeah, there it is. There's the mass. And so since it's the same mass each time, I put the dollar signs, and then, yeah, and then also we're lucky here because we can use the fill handle because we have these three volume numbers right here. So we just have to type it in once, hit enter, and then use the fill handle to fill in the other ones. Now, how do we do the error? And it's the same formula. This is the one we use for the volume. But now we have something where we're taking the mass and dividing by the volume. And you look down here, you have F equals AB. Now we switch to F equals A over B. And you notice it's the exact same formula. And in this case, we set it up because it's r squared. We did plus minus r over r squared plus. We did it twice just to make it a little easier on ourselves. But now what we have is the plus minus volume divided by the volume squared. Then we have the plus minus of the mass, which is over here. Is it not quite wants to get onto the screen? Let's see if I can bring it onto the screen for you. Yeah, so right there, the plus minus over that. And I use the dollar signs once again because I know I can use I anticipated that I can use the fill handle. So there's the plus minus divided by the amount for the volume, plus minus volume divided by volume, and plus minus mass divided by the mass squared, adding in quadrature. And why don't I just go ahead and use my tablet here, and I'll write it out for you so you see it. So we want to do the, okay, hold on. Yep, escape key. So the plus minus density is equal to the density, times the plus minus volume over volume squared plus the plus minus mass over mass squared, and then we square root it. So we'll go back and you can see it now. So M18 is the density, so that's here. L18 is the plus minus volume. K18 is the plus minus volume. L18 is plus minus volume. K18 is the volume. And then you square it, and then same thing over here with the mass, which is up here. And then we come up with the plus minus density. And then we can go ahead and use the fill handle because of the way we set things up. Okay, great. All right. So now we have our accepted values. And we run into this business where we goofed when all the time we thought we were supposed to do grams per millimeter cubed, but our accepted value is in grams per centimeter cubed. So first thing I had to do is create this column. But now you don't have to do it yourselves. I made it for you. And I even included this, I'm pretty sure. Let me go back and look at the one I posted. Right, so I did it for you. There it is. So now we go back and watch what we do now. Density measured, this is the ruler. So we're going equals to, and this here. Now we have to use our F4 key and put the dollar signs into it, because if we don't do it, we won't. We want the same number here, because we're going to compare our measured value against each one of the accepted values, because one of the things we're trying to do is determine what's the actual material we measured. And then this is simply the absolute value of the difference between them. I'm calling it the discrepancy. And then I just put here, that's the plus minus on my density. And you see I once again put the dollar signs. And then I used the fill handle to put all of them in there. At the moment, I have this sorted from least dense to most dense. And then what I'm looking for is, first of all, the smallest discrepancy, which is here. So in this case, with the ruler, it's most likely it's brass. And then I have now, let's see, what is this number? So this is the relative uncertainty on our measurement. This is another way to judge how we did, and it's the relative measurement uncertainty. So it's the plus minus density divided by density, and then I multiplied it by 100 to get percent. So we have a 0.6%, which is damn good, right? As long as we're very trusting of all our numbers here. Remember, we did some fudging on these numbers, and no criticism of our colleague that provided these numbers to us, right? We were all kind of overheated, and I was making mistakes. So, the most important thing now is to focus on the process. So what I'd like you guys to finish up is now I've done this for the ruler. So now this is the calipers. See up here, see the dollar signs, and it's just the exact same thing here. Don't forget, you can pause this so you can see that formula. So that's just the difference between the two, right? And then this is the plus minus density up here. I calculated the percent uncertainty. It's not percent difference. This is the relative error times 100 to make it in percent. So now we went down to 0.18% from 0.6%. And then with the calipers, we went all the way down to 0.14%. Now again, this number here we're calling FOM, our figure of merit. And we're going to discuss that another time. And that's basically the difference between the two values, subtracting it from it, start out with our error bar, basically our plus minus, and we subtract the difference. And so what we want to see is we want this number to be positive. And we want it to be small, we want it to be positive. If it's positive, that means that our error bar is bigger than the difference, and that tends to tell us we did an okay job. But again, we're going to more fully discuss this next time. I don't want to overload you, so I want to get this thing all finished up before we move on to our next discussion about how to think about our results. So we want to have these filled out. We've got, well, I've already done this for you. All these three tables are the same as far as accepted values. Then I put in, escape key. I put in my measured value, which in this case is from the calipers, M20. I put the $, so it's there for each one. The discrepancy is the difference, and I'm using absolute value because I don't care about the sign. I just want to know how much different it is between my measured and the accepted. So the simplest thing right away is we're trying to figure out what's our material. And every time I think it's brass is the closest one. And I haven't, let's take a look here. Discrepancy. Yeah, it looks like every time it's brass for this particular set of data. You guys, remember, you all had different materials, so don't sweat it if you don't get brass as what you measured, right? Because you may not have had brass. Then we want to copy down here our plus minus density. See, it's here on the left. And once again, I use the $. Then we just want to take that number. We take the plus minus here, divide it by the value. That's the relative error. And we multiply it by 100 to get the relative error in percent, this is for humans to look at, so we can feel good or bad about what we did. And so the last two columns are basically the two things that in this particular case. So remember I mentioned there's no set one way you process data. You have to decide what you want to present to the outside world. And for us, as again we'll discuss, that we want to say that we are, by looking at the percent of making the relative error into a percent, we can make a statement of how good of a measurement we made, and in some sense how careful we were. We may not be right, but our technique was good. And then we can use the accepted values. Let's say we were just trying to prove that we had good technique. Everybody knows the densities of these materials, but let's say we were developing a technique to sort materials, and we want to show people that we're capable of sorting the materials. And so we would quote this relative uncertainty, and we would quote this so-called discrepancy here. And the difference between, it's basically comparing our error bar to the difference between what we measured. But we'll get into that another time. Okay, so yeah, I feel like I should hold these equations open like this, but since it's a recording, you can just pause it and make sure you got it right. And oh yeah, notice that. Oh yeah, and it doesn't matter because I'm providing you with this. So see that C2 is, if you copy paste your data into this updated spreadsheet, then you know that any of the addressing that you see here is going to match. You can compare a formula, and you should see the exact same letter and number for the addressing of each of the cells. Cool. All right, so I'll get this up onto YouTube, and I'll send an announcement, and then we'll be all ready. See you soon.